So in this section, we're working on repeated sampling and significance levels. Basically, you need to understand how drawing repeated samples from a large population results in a more accurate estimate of the population mean. Now, that's covered in the learning guide, so I'll just leave it for you to read those sections. What we're going to zoom in on in this lesson is we want to be able to understand what is meant by a significance level and a confidence level. And these two terms these two concepts are related to one another. And the big thing we want to be able to do is determine if the findings of a statistical study prove or disprove a claim at a given significance level. And if we can do that, that'll take us a long way to understanding what is meant by significance level or a confidence level. So I'm just going to give you a general outline of what these problems are going to look like, and then we'll go through, I think, 2 examples of how you actually solve one of these problems. Basically, in these questions, you have done some sort of an experiment or taken some sort of a sample, okay? And there's always something that you expect to be true before you have actually done your experiment or taking your sample. And that's usually refers to the population that you're drawing your sample from. Now, from your sample, you come up with some finding, some result based on this sample. And the question you're always asking is, are the findings of the experiment or are the findings from the sample different than what you expect given what you know about the underlying population? And the way we phrase this question is we ask, how likely or what is the probability, okay, are we to find this result purely by chance? If what we are assuming about the underlying population is actually true. So if we assume the expectation is true, if we assume this stuff over here. So the general steps that you go through in approaching a question like this is first, while you read the question, you identify what the expectation is, or what you expect about the population, and what you are finding from the sample. And remember, it's this finding, this thing, this result from the sample that you want to find the probability of. Two, you should identify your significance level. Now, sometimes this is going to be given to you in the question. Sometimes you're going to have to choose it. But the significance level is basically a threshold of probability that you're going to choose in order to see whether or not your result is significant. So if the finding from your your experiment is very, very rare, so it has a very, very low probability of happening, that in turn means that the finding is significant because it's not likely that it's not going to happen by random chance. So you're looking for small probabilities, okay, if you're going to show that something is significant. Okay? Now, in order to find this probability, you're going to need to know the population mean and the sample standard deviation. So there are basically 2 types of distribution that you're going to be using here. You could be using the normal distribution, in which case you'll see in the question that they give you the population mean and something to do with usually the population standard deviation. Now, I put sample standard deviation in orange here because it depends on properties of the population, and it depends on the number of things in your sample. If you don't see a standard deviation given to you in the question, then you're using the normal approximation to the binomial distribution rather than using the normal distribution. So in both cases, you're going to be using the normal distribution, but in other cases, you're going to be using the normal approximation. The tip-off that you're using the normal approximation is things are given as percentages or probabilities in the question. Okay. So once you've figured out your population mean, your sample standard deviation, you can go ahead and find the z-score for this thing that you're trying to find the probability of, the result from your survey or from your experiment. Okay? And then from your z-score, you're going to calculate the probability of either getting a result that is greater than that or a result that is less than that, depending on whether your finding or the result from your sample is greater or less than the mean. And this will be more clear as we go through an example. So once you have that probability, you're going to compare that probability to the significance level that you had at the beginning of the question. So if you find a probability that is less than the significance level, then the finding is significant. Or the results are true, or they contradict what you assumed about the population. Okay? What it means when your probability is less than the significance level is that there's a very, very low probability of you getting this result simply by random chance. So this is a real result that is telling you something is different in your sample from what you assumed about the population. Okay. Conversely, if its probability is greater than the significance level, then your finding is not significant. So we'll sort of label these steps as we go through our example here. So here's our example. An insurance company claims that 38% of automobile accidents occur within 5 kilometers of home. The company examined 400 recent accidents and found that 120 occurred within 5 kilometers of the driver's home. Does this result support or refute the company's claim? We want to choose a significance level and justify our choice. So first off, what do we expect to find here? Well, we expect that if 38% of the automobile accidents occur within 5 kilometers of home, and we look at 400 of these accidents, we expect that 38% of those 400 will occur within 5 kilometers of home. So our expectation here is 0.38 times 400, or 152 are within 5 kilometers. So that's our expectation based on sort of the underlying population. Now, what was our finding from the experiment here? I should underline this in green instead. When we actually did the testing, we found that 120 were within 5 kilometers. Not the 152 that we expected. So the question we're going to ask is, how likely are we to actually get 120 accidents within 5 kilometers if we really should have gotten 152? So here's our question. How likely are we to get 120 purely by chance? Okay. If there's a low probability of us getting this by chance, then our result is significant. If it's a high probability, if we're really likely to actually get this just by random chance, then our finding probably is not significant. So the probability that we're going to find is the probability that x is less than 120. Okay? How likely are we to get a result as low or lower than 120 if we should have gotten 152? Okay? And we choose below 120 because 120 is below our expected value of 152. What about, okay, number 2 is our significance level here. So they don't give us a significance level, so we're going to have to pick one. We are going to pick 95%. Oh, sorry, not 95%, 5% is going to be our significance level. Okay? That corresponds to a confidence level of 95%. So if our threshold for our results being significant is that they have to be lower than 5%, we will be 95% sure that our results are significant if we use this level. So we'll say that this is 95% confident. So we need our mean and our standard deviation. Now, if I read the question again, they're not giving us a standard deviation. This suggests we're using the normal approximation to the mean. The other tip-off is we're given a probability here of 0.38. That's the probability of an automobile accident being within 5 kilometers of the home. So if they give us a probability, definitely we're using normal approximation to the binomial distribution. So what is our population mean going to be? Well, it's NP, or 400 times 0.38, which is 152. So our expectation is always that we're going to get the population mean. Our standard deviation, our sample standard deviation, is given by n p1 minus p. So subbing in those values, 400, 0.38. See, 1 minus 0.38 is 0.62. Square root. So our sample standard deviation is 9.7. So step 4, we want to find our z-score for the finding that we're testing. So our finding is 120. We're comparing it to our population mean of 152. So 120 minus 152 over 9.7. Working this out, this gives us 3.30 standard deviations, and this is going to be below the mean. So looking this up in the table, a z-score of 3.3 corresponds to an area of 0.4995. So what area are we looking for? Well, if we imagine our normal distribution here, we got a factor mean of 152. Normal distribution like this. We are interested in this value of 120 over here. The area that we've calculated here is this area in here. The area that we want is this area outside, okay? Because we want to know the probability of getting a value that is further away from the mean, or as far away from the mean or further away from the mean than that 120. So our probability of x being less than 120 is going to be, we've got to do 0.5 minus 0.4995 gets us 0.0005, or 0.05%. So there's only a 0.05% chance that when we take a sample of 400 accidents, that we would get 120 of them, or more, or fewer, within 5 kilometers of the person's home. So this value here, we want to compare it to our significance level. This is less than that 5% significance level that we had identified at the beginning. So this tells us that the result is significant. It's very unlikely that this result is just due to random variations in the data. So our final conclusion is that the result, let's say, refutes the company's claim. So it turns out that 38% of automobile accidents don't occur within 5 kilometers. It's actually a different number.